Hello everyone, my name is Shobit. I'm going to present the topic which is Generative Adversarial Networks, GANs for short. This presentation moves around GANs and my contribution in the domain of GAN. First, we will see the generative modeling, then the mesmerizing thing of this presentation, which is its applications. After that, GANs components and its architecture. At the end, my contribution in brief. Then I will be open for the questions. Before come to the main content of this presentation, let's play a game. What I have done, I have mixed the real images as well as fake images together. So fake means the generated one through the GAN. So you can give your responses through your mobile phone. I am showing you the first image. Yeah, so approx 88% people are saying that this is the real image. Approx 78% people are saying that this is the real one. Approx 72% people are saying that this is the real one. And approx 99% people are saying that this is the real one. Actually, these peoples does not exist. These are generated through the style GAN 2. That's the power of the GANs that can generate realistic samples that resembles the features of the normal human being. The basic idea of generative modeling is density estimation. Given a data point over the plane, model have to find out the probability density function followed by these data points. Here is an example where several data points are distributed over the plane. It is estimated by the bell curve. The bump signifies here that the effect of data points are more at that point. That bump is also called the mod, and that will useful for us to understand the concept of the mode collapse. That problem happened during the training of the GAN. Another way to describe the generative modeling is given a machine which is taking the samples from the known data set and which will generate the new samples which follows the similar distribution of the previous data set. That's why it is able to generate the realistic samples that resembles the features of the human being. The GAN was created by the Ian Goodfellow. He is featured in Fortune 40. The popularity of GAN is that much when you search it on Google Scholar, it shows around 90,700 results. It is having 33,300 citation on the original paper of the GANs. According to this curve, the number of paper published over the month is increased exponentially. In 2014, the face generated by the GAN is black and white, and it is not fine tuned, not look like real image. It's more inhuman. But in the span of 4.5 years, that you can see the image generated by the GANs are colored as well as it is look like real, more fine tuned. GANs have several applications. I will tell you some of the coolest applications of the GAN. First is cycle GAN, which is the image to image translation application, which is translate the image of one domain to the another domain by intact the features of the previous domain. In the first example, you can see that we convert apple into orange. In this, that important features of the apple like stem is propagate to the orange. You can see that stem is also present in the orange. When you convert the orange to this apple, you cannot able to find that any stem in the apple. More examples like you can convert summer to the winter, winter to the summer, zebra to the horse, horse to the zebra. This cycle GAN is used to any unpaired image to image translation. Another application of the GAN is the NVIDIA GAO GAN. Due to this, everyone become the artist. You just need the imagination. You can draw anything by putting some rough brush strokes. This paint over is done by the collie. So what he have done, he give the segmented input to the Gaugan and Gaugan give this mesmerizing output. After that, collie done some paint over it. This Gaugan is used by many renowned artists and for their renowned projects. So this is basically Gaugan is basically the Doodles to the image translation app. If you have watched the Harry Potter, you must know this application that in the Hogwarts there are talking portraits. So in this GAN application that you can give the still portrait to the GAN and it will animate by using the motion of any person like me, you, anyone, that it will not look like a Mona Lisa to play the part. GAN is used by almost every company in some forms. That I listed the some of the major companies which is heavily depend on the GAN. So first is NVIDIA, which use this GAN for its AI playground, which having a set of applications. Some of the application it have like cow GAN in painting, etc. IBM used GAN for the data augmentation. Adobe used for the next generation Photoshop. Uh, Google used for the text generation. The TikTok and Snapchat is used for the image filters. Disney is used for the super resolution. Why we required the GAN? GAN can simulate all possible future plans. It can tell you the missing values. For example, that consider this image having the several missing values. But through the generative model, it reveals that this image is containing the face. Next is realistic generation task. You already seen in the game that but through this style GAN you can generate the realistic images. In the GAO GAN you can generate the realistic paintings. Next is multiple correct answers. So if you instruct the GAN that generate the image like kids are playing in the park, so it can generate several images. All are correct one. Next is data augmentation. That is the important application is in GAN. So the success of the deep learning project is depend on the data. If you have a more data, your accuracy will be high. So if you consider the sectors like medical, so in the medical sector we do not have the that much data. So through the GAN we can generate more data and we will get a high accuracy for the medical projects. Let's see the components of the GAN. GANs have two components. First is generator, second is discriminator. Generator task is to generate fake data that look like real. If you see here that these are the some samples which is generated by the generator. It is like a art forger. Next is discriminator. Discriminator is task is to distinguish between real and the fake. So it have to identify that which images is coming from the data set and which is coming from the generator. Accordingly, it will distinguish like that it is telling that first image is the fake one, second is fake one, third is real. Like that, it will tell with some probability that this is the real and this is the fake. So we take the highest probability. So if you closely observe, this boy image is having some features of this boy and this lady. Let's see each components of GANs in detail. Let's first see the discriminator. Discriminator is also called the classifier. To train the classifier, which having several neural layers, we required some training data set. So at the beginning, you can see that we give the input as a bird. At the beginning, it may give the class like it is a tiger with the probability of zero point 0.6. It is a bird with the probability of zero point 0.4. It is a cat with the probability of zero point 0.5, like that. But as you train your neural networks, all the parameters are adjusted. Then at the end, we give this image again to this neural network. Then it will give the result like it is a tiger with the probability of zero point 0.1. It is a bird with the probability of 0.99, like it is a cat with the probability of 0.01. Let's see that how the training of the discriminator is performed. Let me clear you one thing, that discriminator having only two classes. In the previous slide, we see that classifier is classifying three classes like tiger, cat, and bird. But here discriminator have only two classes like real or the fake. So let's see how the training of the discriminator is performed. So given the feature X, which is generated by the generator, we give to the discriminator, and discriminator have to distinguish that it is a real or fake. It will give some probability of the real, that that particular feature can be a real, or it will give some results in terms of probability that it may be the fake. So that output is y cap, and then we give the real labels as well, that whether that particular feature we provide to the discriminator is coming from the generator or it is coming from the uh, that data set. So after that, accordingly, that loss will be calculated, which is j theta. After calculating that loss, the error will be back propagate. So after the error is back propagate, all the parameters which are trainable can be change their value according to the loss function. Let's see the small example of the backpropagation, that how the backpropagation is performed, how the loss can change in the loss can also change the value of the trainable parameters. So here I'm taking the small example. This neural network have only three layers, this layer 1, layer 2, and this layer 3. And in the forward propagation, that first it calculate some linear equation, and after that it provide some non-linearity by using the activation function, it having the trainable parameter like w1, w2, w3, like b1, b2, b3, like, and at the end we calculate the loss. After that we have to propagate this error throughout the network. So how we backpropagate? We use the differentiation. In short, we have to find out the change, that what will be the value of the W3 after the change in the loss. So that can be calculated through the differentiation. For example, I want to calculate what will the value of the this W3. So that can be calculated by dz3 into a2. So this is done through this differentiation, that dl by dw3 equals to dabba l by dabba z3 into dabba z3 by dabba w3. This dabba z3 is calculated through this equation dl by dz3. So similarly, if I want to find out the change in this W2, so that can be calculated through this dabba L by dabba Z2, dabba Z2 by dabba W2. This dabba Z2 can be calculated by this formula, and like that. So in short, we use the chain rule to calculate the any trainable parameters. Let's see the discriminator in terms of probability. Here we are using the conditional probability. So here what we are doing, given an image X, which is consider that given a feature X to the discriminator, it will provide you some probability like what is the probability that this is the real, what is the probability that is that particular feature is fake. So in short, the discriminator task is to estimate the probability density function, that it at the end of the training it is able to distinguish between real and fake with the correct result. After the discriminator, let's see the structure of the generator. So for the generator, we give the input as a noise vector. This noise vector is follow some distribution like Gaussian distribution, normal distribution, like that. So here we give some input like 2, 1.53, etc. Like that. We give input noise vector to the generator. Generator have some neural network and can be ANN, CNN, like that. So after that, it will produce some feature X that will be at the beginning that is not realistic, but at the end it may be the realistic features. Let's see the training of the generator. That for the generator, we give the noise vector to the generator. Generator will generate some fake feature X cap that will be give to the discriminator. Then discriminator have to identify that whether particular input fake features input which is a fake feature is that at what probability that features are real, at what probability that feature is fake. So it will give the output y cap. At the end, for here for calculation of the loss, we are giving the one as the real level, because we want the generator should generate the images or the features, we can call that feature, which is realistic. So after calculating this loss, the error will be backpropagate and all the trainable parameters are trained. Let's see the generators in terms of probability. So we have to generate some feature X in the generator. So we use here the conditional probability. For example, for a given generator, we want that first it will generate the human images. Next, it can generate the cat images or a dog image, like that. So for that we give it a different classes, so accordingly the generator will generate the features. So here it is generate the humans. For example, if we want that our generator is generate only a one type of class like human, so it will approximate the probability function this and generate all the possible faces. Putting both the generator and discriminator together, let's see that how the training of the generator and discriminator is performed. So let's see this, the two robots are doing the arm wrestling. So we train the discriminator and the generator like that. So we have to take care one thing, that we have to train both discriminator and generator together. Like that this is train, we the muscles are growing, the discriminator, we train the discriminator like that. We have to ensure one thing, that we have to train the generator more than the discriminator. Why? Because the discriminator have to predict only two classes, but the generator have to generate the more number of features. The dimensions of the features is very high. If you do not take care of this thing, then the problem like mode collapse will happen, that we will see at the end of this slide. This is the GAN model. We give noise to the generator. Generator will generate the fake feature, and we give to the discriminator. Discriminator not only take the input of from the generator, it is also take the input from the data set, which is called the real features. And at the end, it will produce some output. And accordingly, we train discriminator and generator simultaneously. There are several difficulties which we can face during the training of the GAN. First one is non-convergence. What happens that our generator is stuck in local optimum. It unable to find the global optimum. It hinders around some garbage. Second problem which we face is mode collapse. Let's see what is mode collapse. Consider this 2D plane. So here in this 2D plane, that there are several points which is scattered in this plane. So like this, there are several points. After that, there is some probability density function which estimate these points. Considered that this is a one probability density function which estimate these points, is another, and this is the third one, like that. So here the bumps is the mods. So these bumps are called the mods, and here in this graph, that it is uh, it is uh, uh, it is the point, like this is, this point is signifies the one mod, this is another mod, like that. So consider this particular points is of 0, this is for 1, like that. Here also 0 1, like that. So above 1 is the ideal scenario, the below 1 is the practical scenario. So at the 0 step both are equal, but you can see at the 20k step it is start generating a different type of images like 0 1 2 3, but is stuck in the to generating the one type of image only. We can see only one mod here because all the mods are collapsed together. So at 25k also, but here in the ideal scenario it can generate all the other images as well. So what happened, that why this happened, that because of the because that we train our discriminator too much. Due to this, that it unable to distinguish real and fake correctly. So that's why this problem happened. So you can see that in the above image also, that it is at the beginning that it is generating a different type of images as well, but at the 100k step or 50k step it is start generating a same type of images like 6 only. Now let's see my contributions to the projects of the GANs domain. I have used this GAN for the malware detection purpose. That the domain of my project is novel malware generation and the detection. The whole idea is to detect the malware which haven't seen yet to secure our system from the future attacks. To generate the new malwares, attackers are doing code polymorphism, code mutation, code obfuscation, and self-modification to generate the new malwares. So whose distribution is similar to the previous malware distribution. High level overview of my mode CGAN is like that I have used two different autoencoders to get the important malware features. I concatenate them and generate the new malware features. I save them into the database. I use that database for the new incoming malwares. I used the cosine similarity to do the similarity between the new malware features and the generated malware features. Accordingly, I set some threshold and I can identify that particular incoming file is the malware or the benign file. If you want to know more about my project, you can go just before this slide and go to the YouTube link where you can get the detail of this project. These are some links of the cool application of the GAN. So this Wombo.ai is for converting your still photo into the motion. This in painting is to remove somebody from the image. For example, you go to some beach and you want to remove the other people from there. So you can use this in painting GAUG, and you know that for the for painting purpose. And similarly, you can try these as well. Let's see the summary of this presentation. GANs are generative models that are implemented using two stochastic neural network models. First is generator, second is discriminator. The generator tries to generate the sample from the random noise. We already see that this random noise have to follow some distribution like Gaussian or something like as input, and discriminator tries to distinguish the samples from the generator and the sample from the real data distribution. Both networks are trained as adversaries to fool the other component. In this process, both models become better at their respective tasks and can be trained using backpropagation. We already see a small example of the backpropagation for neural network based generator discriminator function, and sharper image can be generated here that it is the faster to sample from the model distribution. Here in the single pass we can generate a sample. We do not require a multiple pass to generate a single sample. We require only a single pass like